Okay, good morning, everyone. Okay, how did your homework go? Okay. All right. So we start by putting the main identity that are going to be our guidelines today. So the first identity is equal 1 minus sine, or 1 minus cosine square, which is really mean the same thing. And then we have 1 plus tangent square equals secant square. And then we have secant square minus 1 equal tangent square. Okay. So this will be our guideline for this whole lecture. So I'll look at your problems and then I will proceed to do extra problem today. So I'll look at number 18.
Can you move the paper up real quick? Thank you.
Number 18. Okay. All right, so number 18 is you have to find the antiderivative of the following function. 1 over 1 plus x squared to the power 3/2 dx, of course. Right? So, okay, here we're gonna set up x to be, so we have really a square root term here, that's the power 3/2, and you basically wanna get rid of it. So I'm gonna set x to be, I usually look here, which one will help me to get rid of, will create a square. So it's this piece, so x equal tangent theta. Okay. And actually I should have written theta here, not that it matters, but so theta will be a little bit less confusing for you. So theta, theta. If you guys are writing, you can change it to theta. Okay. All right, so once I make my substitution, and the rest is substitution. As I said yesterday, in this situation, x is given on a function of theta. It means the old variable in terms of the new variable. Usually the new variable, u, in terms of x squared. Now it's the other way around. But nothing changed. So when we have the x and we find the derivative here, it's the derivative of tangent secant squared d theta. Okay, so be very careful with the variable. That's where students get kind of confused. So now everything in terms of my new variable. The x is this one. And 1 plus x squared will become 1 plus tangent squared theta to the power 3/2. Okay. And now, as we said yesterday, and I will repeat like a million times today, our goal is not to have the square term anymore. And this is by creating a complete square here. So this one will give me the secant squared theta to the power 3/2 d theta. This is equal to. Now, secant squared theta to the power 3/2 would give me secant cube. So that would leave me with secant cube times the secant square. And finally, this I will end up with secant square over secant cube is 1 over secant theta d theta. Okay. So we transform one integral into another. And usually the goal is to transform it into an easier one, something that we can work with. All right, how can I proceed now? How should I proceed? Idea, anybody?
1 over secant equals the ln of the secant of theta plus tangent of theta.
Okay. All right, what's the mistake? The one I established yesterday is the integral of secant is equal to that. Is
Yeah,
this
do
secant?
1 over that.
Absolutely not. Absolutely not. Let's see why. Is the integral of 1 over f of x equal 1 over the integral of f? Can I split like this? That's what you're telling me, right?
Yeah. For some
Is this
reason that worked for me on my assignment, but no, yeah, that
no,
should work like that.
I don't know what worked for your assignment. I don't know. But it's a major error. Is this correct? If you're
No.
reluctant, what?
No, it's not.
Yeah, absolutely. Absolutely. Integral of 1 over x dx is not by any stretch of the imagination 1 over the integral of f of x. We cannot split the integral. This has to go. All right. So I don't know what happened in your homework. I don't know. All right. Nibadia. So one of your classmates is telling me switch, and your classmate is correct. What's 1 over secant? 1 over secant is basically 1 over cosine, which is the cosine of theta. So 1 over secant would look a little bit complicated. It's actually not. It's nothing more than the cosine of theta d theta. Now, entire derivative of cosine is sine theta plus c. And now we have to go back to x. And how do we go back to x? Do we go back to x? We ask ourselves, what is the relationship that initially existed? Because this is in terms of theta. I have to go back to x. I said, okay, what was initially the relationship between them? So back to x. Okay, so initially I have x equal the tangent of theta. And my integral so far is the sine of theta. So now I know the tangent in terms of theta. I need the sine. So one way to do it, as we did yesterday, you take a rectangle, and your rectangle, you label, you pick one angle to be theta. It doesn't matter which one you pick. You can pick this one or that one. It doesn't matter. You label, so the tangent is x. The tangent is opposite over adjacent. And then the hypotenuse now would be 1 plus x squared. And so the sine.
I have a question.
I'm listening.
Where'd you get the 1 from?
Because this is x over 1.
Oh, okay.
So you just pick it. You know, it's just you choose this is x and this is 1.
All right.
So the triangle will fit the definition. So if I make this, take my triangle and compute the tangent of theta, I'm going to get x over 1, which is x. So you label it so the picture would fit. So finally, it's going to give me x over square root of 1 plus x squared plus c. So I wonder how the MATLAB gave you right answer if you put ln. No way. No?
One more question.
Mm-hmm.
Why is it x over 1 over x squared?
What's the sine of theta? Because the antiderivative ended up to be the sine. Let me go back to the picture. We integrated. We got 1 over secant. But 1 over secant is actually a cosine. The derivative of cosine is the sine of theta. I have to go back to my original variable x. Okay. So what was the original relationship between x and theta? X was the tangent of theta. So I need the sine of theta. I know the tangent, I need the sine. So I draw my rectangle and then, my triangle, and I find the sine theta, which is opposite over hypotenuse. And that will give me the final answer.
Oh, okay.
Mm-hmm.
All
So
right,
let's look
thank you.
at number 29, and then we will proceed, and hopefully we'll finalize this section today. So number 29. Okay. It does not involve a square root term, but we're going to use the same technique to evaluate because we don't know any other technique. Okay, so that's really my integral here. So as I said that it's a hard integral, honestly. The substitution doesn't get me anywhere because if I put u to be 4 plus x squared, the du will be 2x. It's very hard. There is no factor, no partial fraction decomposition inside because this is a square. This cannot be factored, and it's square, so I have no idea what to do with that. So we were going to use the idea of this section. So we're going to set x to be, and somehow get rid of this 4 plus x squared. So since it's a plus x squared, we're going to set it to be tangent theta. Tangent theta will get me nowhere because I will have 4 plus tangent square, which is not simplified. I'm going to multiply it by the 2 so I can factor out the 4. So this will give me that the derivative is 2 secant square theta d theta. And now I'm going to do my substitution verbatim. My dx is this piece right here. And this I will have 4 plus x squared. X squared means x times x. It means 4 tangent square theta. Okay. And now this is equal to. Of course, the idea is to simplify this expression. I'm going to factor out my 4. I will be left with this piece right there. And the whole thing squared times 2 secant square theta d theta. Okay. All right, let's see what we get from here. Right. Now, some of you used to put their camera on. Now, none of you is. And I really ask you to put your camera. That makes it much easier. Or I'll take points off because you're not helping me. Okay, what I'm going to get here. 1 plus tangent square is secant square. So now I'm going to have 4 secant square theta to the power 2, which is going to give me 4 times 4, 16. Secant square, secant 4 theta. Right. Now we put the whole thing together. 2 over 16 is 1 over 8. Secant square over secant 4 will give me 1 over secant 4 theta d theta. So this would give me the following. 1 over 8. Good. 1 over secant 4 is equal to what? Quickly. We just did that. We just did what to deal with 1
Cosine
over.
4 theta.
Right. It's going to be cosine 4 theta d theta. All right.
How is it still secant to the 4th power?
It should be secant square, right? Okay. Cosine square. Very good. Now, how to integrate cosine square? What do we do with this integral? Remember, we did work with those.
Half angle.
Exactly, half angle formula. So it's 1 over 8, the integral of 1 plus cosine 2 theta d theta, because we've learned that. So we're using the half angle formula. Okay. It's equal to 2, that's a constant. I can pull it, give me 1 over 16. And then I will be left with this integral. So that's a nice problem because it's going to bring up one idea. I mean, one more formula that it's used a lot in this section. And I will get to it in a minute. All right. Now we have to find the antiderivative times. Antiderivative of 1 is theta. antiderivative of cosine 2 theta. You remember, because I have the 2 in here, I need a substitution, or I told you you can memorize the antiderivative of those. It's a half sine 2 theta plus c. Okay, so I found the antiderivative, but the problem that it's in terms of theta, I need to go back to x. So right here, we need to go back to x. Okay, to go back to x, I go back basically to the initial relationship that existed between x and theta. So the initial relationship is that x is 2 times tangent theta. Okay, so that's really my relationship. And now, what do I need? From this, I need theta, and I need the sine of 2 theta. So both I have the tangent, I need theta, and I need sine 2 theta in terms of x. So took a little bit a nightmare, but we will get it. How can I find theta? X equal to tangent theta, so I'm gonna solve for tangent theta in terms of x. Okay, what's theta in terms of x?
Inverse tangent of x over 2.
Here you are. If the tangent is x over 2, it means theta is arctangent x over 2. I took care of the first piece. Plus. Okay, so I took care of theta. Sine 2 theta is problematic. Sine 2 theta is problematic because I have tangent theta and I want sine of 2 theta. But there is a formula that's called double angle formula. I promise you that's the last formula in this section. So the double angle formula, but it's going to be used quite a lot on those problems, double angle. Double angle formula tells me the following, that the sine of 2 theta is 2 times sine theta cosine theta. Okay, so please, that's one of the formula you will be using. So please write it up. Sine of 2 theta is 2 sine theta cosine theta. So this piece here now, I didn't extend in terms of x yet, but this is gonna become sine theta cosine theta. So now I only have to find the sine and the cosine. So I know the tangent, I need the sine of the cosine. All right, so I'm gonna go back to my triangle as usual. This is my theta, and I'm gonna label it so that tangent theta equal x over 2 will be reflected in here. That's how the labeling will go. So how can I label it? I'm gonna label the high, that's to be x, to fix, so the picture will fit, and that's to be 2. Now the tangent is x over 2. Now I want the sine and the cosine. So to get those, I need the hypotenuse. Pythagorean theorem would tell me that's going to be 4 plus x squared. And now I know my sine and I know my cosine. So the sine of theta would be x over the square root, and the cosine is going to be 2 over the square root. And finally, it's a long problem, but it brought up this formula, which it's used a lot in this section. So finally, I will have, so instead of sine of theta, I'm going to put x over that. Times the cosine, which is 2 over it. Now I can simplify a tiny bit. I will have 1 over 16 times arctangent x over 2 plus 2x over the square root of 4 plus x squared times it gives me 4 plus x squared plus end of the problem. Okay, so it's a long problem, but It's not bad. It's not actually bad at all. That's the formula that we're going to use since it's going to come up. It's going to come up in this section, and we need it.
Quick question. So when you're doing the triangle, could you have done the opposite side as x over 2
Yes,
and the adjacent side as 1?
absolutely. You can make this x over 2 and this one.
Okay.
But I think it's harder because then the hypotenuse is going to be the square root of 1 plus x squared over 4.
I have a question.
Yeah.
Where did the 1/2 go from the 1/2 sine
Yeah.
of 2 theta?
Yes. The double angle tells me sine of 2 theta is 2 sine theta cosine theta. And I have a half here. So this should be a half times 2.
So just cancel off.
Cancel out. Yes.
And does that double angle formula work for any number? So if it's like sine 4 theta will equal 4
No.
sine.
No, be careful how we read the formula. So double sine 2 theta is 2 sine theta cosine theta. Okay. So sine 4 theta, that's a good question. I didn't think about it that way. Yeah, it's going to be, the 2 has nothing to do with the 2 in here. That's the formula. It's going to be 2 sine 2 theta cosine 2 theta. You see how the formula works? The angle is, if 2 theta, it's theta here. This 2 has nothing to do with that 2. So if I have sine 8 theta, it's going to be what? 2, that's part of the formula, sine of 4 theta cosine of 4 theta. Do you see how the pattern works?
Yes. Okay, that makes more sense now.
Yes, yeah. This 2 and this 2 have nothing to do with each other. It's part of the formula. What's going to be affected is the angle. So the 2 theta is become theta, the angle. 4 theta became 2 theta. 8 became 4. The 2 is part of the formula. That by coincidence, it's a 2 and a 2. I mean, that's how the formula works. Okay, shall I move on?
Thank you.
Okay. All right. So now, as I said, we're going to move along the same line, and we're going to I worked a lot with tangent, and now we're going to work with others. So suppose I want to integrate the following. 4 minus x squared dx. Remember, all those are integral that we have no idea how to do, no idea. Basically, none of the techniques we developed actually deals with that. So the question is how to deal with this. And we're going to use the trigonometric identity. Now the question is, which one fit this scenario the most? So these are my guideline, as I said yesterday. Okay, what's going to be the best possible scenario? I want to get rid of square root. These are my guideline. Which one will give me there? Any idea?
Well, minus sine squared x, right?
That's, yeah, either this one or this one. Honestly, it doesn't really matter which one you pick. You can pick sine or you can pick the cosine. It doesn't matter. Okay, so I'm going to pick the cosine. No, pick sine because the derivative is, I don't have to deal with negative derivative. Okay, x equals sine. Well, x equals sine by itself do the trick. If I put x to be sine and I substitute it in here, remember my goal is to get rid of, I will have the square root of 4 minus sine squared. But I'm still stuck. So how I'm going to fix it. All right. Students are telling me, put the 2. Exactly, the 2 will fix it. And now we once we pick the right substitution, the rest is verbatim what we did a minute before. So we're going to do that. So the dx is 2. Derivative of sine to cosine. As I said, you can put sine or cosine. It doesn't matter. I picked the sine, so I don't have a minus in here. So, and now we go back and we do again everything the same. So this is going to be equal to, there is no minus here, the square root of, and my dx is 2 cosine theta d theta. All right, let's see what we get inside. We're getting a 4 minus 2 sine theta square. So verbatim the substitution, which is going to give me 4 minus. This is 4 sine square theta times 2 cosine theta d theta. And this would give me the following. I can factor out my 4. So as you realize, at this stage, we actually repeat what we did. Once we know the right substitution, we're done. Kind of. All right. So this would be. This will be the square root of 4. This is my cosine square. Now I am safe. Okay, so this is going to be equal to integral of. This would give me 2 cosine theta. And this would give me 2 cosine theta d theta. Now this will become the 4. I can take it out. Cosine square. And this is verbatim like a problem I did a minute ago. Cosine square, it involves only an even power of the cosine, and we know when only even, we use the half angle formula.
I have
So
a question.
Yes.
Where did the original cosine, where did the square go? Did it go because it's from
Here
the
you
square
mean?
root?
Here?
Yeah, right here.
Yeah.
Yeah.
Yeah. Because what's 4 cosine square? It's 2 cosine square square if you want.
Oh, okay.
So this would give me 1 cosine square cosine 2 theta divided by 2. So that's the half angle formula. I can take the 2 out. It would give me 2 times integral of 1 plus. So exactly like the previous problem, but there will be, when we go back to x, the picture will have to change because my substitution is not tangent. So my 2 is here now. Antiderivative of 1 is theta, because I have the theta here. Antiderivative of cosine 2 theta is a half sine 2 theta. And now I have to go back to x. I have to go back to x. Okay. So we pick up another sheet of paper and go back to x. To go back to x, I have to go back to initially the relationship. Back to x. The relationship that existed between the theta and x. So initially, that's my relationship. X is 2 sine theta. Okay. And the way we do it, we first express the sine in terms of x. Give me x over 2. Next problem, I make sure I don't have a 4 in it. And now I build up my triangle. And I will label it so that the sine of theta will be x over 2. Now we know that the sine is opposite over hypotenuse. So I'm going to name this opposite, and this is the hypotenuse. Right? And now I need Pythagorean theorem to solve for this side. So if I call this b, Pythagorean tells me that b squared plus x squared equal to 4. Sorry. So the b is going to be, the b will be the square root of, so that's the b, of 4 minus x squared. Okay. Now I go back to my problem. So we ended up here, theta plus a half sine 2 theta plus c. That's really what we ended up with, equal. So now I can remove that and do it. So every piece. I need theta. So what's theta quickly?
Inverse sine of x over 2.
Right. It's inverse sine, arc sine, inverse sine, whatever notation you like, x over 2 plus. And now I'm going to do exactly what I did before. I have sine 2 theta. It's problematic because every knowledge I have is in terms of sine theta. So the idea is, why don't I express this in terms of theta? And that's where the formula comes. So this is a half, and this would be 2 sine of theta cosine of theta. That's what this would be. So those two will simplify, and I will be left with cosine theta. No, sorry, sine theta. That's x over 2. Cosine. I go back to my picture. What is my cosine? Cosine is the opposite over the hypotenuse. Plus c. So basically, that's the integral. Now we can finally do a little bit of math. Not much, actually. The only thing I can is product of the numerator over the product of the denominator. Or you can multiply out by 2 and finalize the problem. All right? Okay. So I would like to do 2 more problems, and basically we leave you. So I'm going to make a little bit of a change to the problem I did a minute ago, a little bit of tweaking, and I'm going to ask you, what do you think will be the best substitution? Okay, so this is my problem now. I'm going to tweak the problem I just gave you. So suppose I give you the following integral. Let us say 9 minus 4x squared. And there are several ways of doing this problem. Okay, so it involves a square root. And the question is, what's the best substitution for this problem that helped me to get rid of the square root? So I'll let you think a little bit about it and see what you guys can come up with. Well, I finished my breakfast. Whatever ideas you come up with, you just put them on chat or just say them, and we think through that. Anybody? Okay, all right. I'm having, yeah, I'm not bad, not bad. Okay, anybody else? I'm gonna give you one hint. Okay. I'm gonna give you one hint that I find it very useful. All right, I have so far how many questions? How many? I have one correct answer. So I want you to keep thinking. Okay, keep writing your answers on chat, whatever you think, put it and see what we come up with. Any more suggestions? Erica, what did you come up with?
I said the x equals 3/2 sine theta
Okay, on what basis?
because 3/2 squared is going to give you 9/4, and then the 4 would cancel and leave you with the 9 to factor out.
Okay, integral of, all right, you get, I agree with her. All right, the way I see it, because I'm not very good at guessing, I said, okay, I want this to be getting grid. So really what I want is, the way I think about it, I want the 2x to be 3 sine theta. Why did I do that? Why I put 2x? Because what I want is this piece here, this piece to give me the 9 sine square theta. So I can factor out the 9. So this will involve that my x should be 3/2 sine theta. Okay, so I know that I have some answers, but that's going to be the correct answer. And now basically I will be done as far as the problem is concerned. It's going to be exactly verbatim like I did the previous problem. So I compute now the dx. So that's going to be the best substitution. Okay, so dx would be 3/2 cosine theta d theta. And now everything verbatim. Dx is 3/2 cosine theta d theta. And this would be 9 minus 2x squared, 9 sine squared theta. Okay, and now it's going to be equal to the integral of, I will factor out the 9, 3/2 cosine theta d theta, and then this will give me the following. 1 minus sine square is the cosine square, and then this will give me integral of 9 cosine square 3/2 cosine theta d theta, and then verbatim like the previous problem, it's 3 cosine theta times 3/2 cosine theta d theta. So it's not hard, it's just we have to get used to it. So here, the main idea, because I have 4x squared, I said, you know, based on what I've done previously, is the 2x here that I wanted to be the 3 sine theta. And that's really give me all the guideline in this problem. So finally, it's going to be equal to the 3 and the 3 is 9/2. And I'm going to repeat actually myself at this stage because we've done this by now. That's the third time around. So it's going to be equal to 9/2 integral of 1 minus, I meant 1 plus cosine 2 theta over that, which give me 9/4, 1 plus cosine 2 theta. And this will be 9/4 times antiderivative of 1 is a theta. That's a half the sine of 2 theta plus c, which is based on what we did a minute ago, it will give me. I'm going to express this in terms of theta because that's what I will need eventually. So I'll have a half sine theta cosine theta. So this will give me 1 plus that. Now back to x. To go back to x, I go back to my initial relationship. X is 3 over 2 sine theta. Okay. And I want to find sine theta in terms of x. So this will give me the sine of theta equal. Okay, I have to multiply by 2, divide by 3. Okay. All right, now I build my triangle. And this is my theta. And I label it. So this is equal to the opposite over the hypotenuse. I can pick my opposite to be 2x, my hypotenuse to be 3, and then I need this side. So this will b squared plus 2x squared equal 9. It means the b is 9 minus 4x squared. And now I have everything. Sine theta is 2x over 3. I solve for theta, it's the arc sine. Plus sine of theta is 2x over 3 times the cosine. The cosine is the square root of 4 minus 9. I meant 9 minus 4x squared. And this divided by 3. End of the problem. Okay. So a little bit of tweaking, but with observation, we can actually make it into a standard problem.
I have a question real quick.
Mhm.
So the theta is always going to be the arc sine of the sine, then?
Yeah, you remember what the definition of sine, of arc sine. So in general, if you have sine theta equal any number, let me call it A, it means theta is the arc sine of A or sine inverse of A. Because the sine inverse is the opposite of sine. I mean, it's the inverse of sine function. Okay, because when I say what's sine inverse of a half, it means what's the angle whose sine is a half, that's pi over 6, which means that the sine of pi over 6 is a half. So that's the definition of sine. What's sine, arc sine of something? It's the angle whose sine is the A. So sine inverse of A is the angle whose sine is A. So sine inverse of A is the angle theta, such as sine theta is equal to A. That's the definition of the arc sine. So in our problem, we had the sine of theta is 2x over 3. It means theta is the inverse sine, or the sine inverse, or the arc sine of 2x over 3. Okay.
Yeah, okay, that makes more sense.
Try
All
to review that a little bit. Okay, review the idea of the arc sine. It's the inverse function. So you have one function that takes an angle to its sine. So that's the sine function. The arc sine does the opposite. You have the number here, and it gives you the angle. It's the inverse function. It reversed what sine does. All right, so my last example here, and I think that will do for this section quite a bit. So I will do the following integral. Now be very careful. Be very, very careful. Square root of 16 minus x squared and square root of x squared minus 16 are very different from one another. Okay, so be careful with what the sign is. This and this are absolutely different from each other. So now what's the substitution that we'll do here? I'm gonna go back, and because I do not memorize any of this stuff, whenever I have this integral, I go to my table, which is the one that will fit. Actually, I put it down here.
The secant squared, or the secant, I guess.
Secant will fit. All right, that's how you realize. You don't have to memorize. That's what I want you to memorize, because you need them for this section and for any, and we already used them. That's the one that will fit the picture. It's the secant square. So I'm going to put x equal secant theta. That's the idea. And then to be able to factor out the 16, we make it into a 4. Otherwise, I will not be able to factor out the 16. And as I said, the rest is verbatim what we've done before. It's just we have to remember the derivatives. Derivative of secant is secant tangent. That's what we have to remember for that. And now I substitute and hope for the best. So let me substitute. Okay, integral of 1 over my dx is for secant theta, tangent theta d theta. That's my dx. And this will give me the following integral. X squared, x times x will give me the 16 secant squared theta minus the 16. And finally, I will get, that's the square root of, I factor out my 16, which would leave me with this term right there. And tangent d theta. Fine, this is equal to. And remember, my goal is to remove the square root, which is problematic. And this will give me secant. Now secant square minus 1, that's the tangent. 4 secant tangent d theta. And now I do the simplification. That's 16, that will give me a 4 tangent theta, 4 secant. Okay. And now the problem simplified, the 4 and the 4 go. Tangent and tangent simplify, and now I will have secant only. So that's secant, not 1 over secant like before. And this will give me the ln of secant plus tangent. Now the last step in the process, back to x. Okay. To go back to x, I have to go back to my initial relationship between x and theta. So x is 4 secant theta. Now I have the secant though. So now this takes care of the secant. I still need the tangent. And now we can build our triangle. So for that, I will first find the secant, which is x over 4. Okay, and now I build my triangle. I pick an angle to be theta. But now let's see, the secant is 1 over cosine. So this will give me the cosine, because I think better with the cosine, is 4 over x, because it's 1 over that. So this will tell me that this should be the adjacent, and that's the hypotenuse. Okay, I switched to cosine because I think better with cosine. So the cosine is going to be the 4. That's going to be the x. Pythagorean, give me 16. Pythagorean will give me x squared minus 16. And my problem is absolutely done now. It's the ln of the secant, which is x over 4, plus the tangent, which is opposite, over hypotenuse. End of the problem. Okay. Right, so with this, we actually covered basically all our cases. And this section, we actually finished most of the technique of integration. So at some point, probably tomorrow, I will work with a little bit the strategy to integrate and some mix and match problem. So each problem, we're going to look at it and decide, which method will fit this problem more than other problem. So to have kind of review for all the integration strategy we have. Okay, so remember you have a quiz tomorrow. And when I graded my quiz last time, I made it very clear. If I don't see work, I will not give credit. So be very careful with the way you're going to make the quiz. The internet is not the way to do the quiz. I don't want you to go and pick up the answer from the internet. It gets you nowhere. I want all the answers crystal clear, all the work crystal clear on your paper. Okay. Any questions?
Can you show that little list that you always bring up?
Yeah. Yep, here it is. But put theta instead of x, because otherwise it will confuse you a little bit in those problems. Okay, the class is dismissed. If anybody has